here is example 4. Example 4, we've got a ball dropped from a tower 70 meters high. So let's just write that down. The displacement of a ball falling down is going to be 70 meters. Actually, I'm sorry, it's not our displacement. It's really our beginning position, our yi. That's going to be 70 meters, our beginning position. Well, what else do we know about this? We can assume that the initial velocity is what? Well, if it's being dropped from the top of a tower, it wasn't moving up there until it was dropped, so the initial velocity is 0 meters per second. The acceleration is still going to be negative 9.81 meters per second squared. Excuse me. And we're actually given 3 times. We're given time equals 1, time equals 2, and time equals 3. So the question is, what's the velocity, the final velocity at 1? What's the final velocity at 2? And what's the final velocity at 3 seconds? Well, the equation that we have that can relate initial velocity, acceleration, and time, and final velocity should be a relatively familiar one to us. That's our final velocity equals initial velocity plus acceleration times time. Again, I didn't write this as VF equals VI minus GT. I simply wrote it as the original equation. If you wanted to, you could write it just like this, minus GT. Again, the only difference would be that you would, when you put in your value for A right here, your value would be negative 9.81. When you put in your value for G right here, since you already put the negative out front, you would simply put 9.81 in front of the in for the G there. So, but I'm going to use actually the first one, and I'm probably going to tend to use that. You can write it either way, but I'm going to simply write it as VF equals VI plus AT, and substitute in the whole value of our acceleration, including the negative, in for A. So VF1, what is that? That's our initial velocity. So it's 0 plus negative 9.81 times, what's our t? That's, well, just 1. So our final velocity 1 is going to be negative 9.81 meters per second. And you know what? I should have written it. I'm going to write in the values right there. Sorry, write in the units. So this is 9.81 meters per second squared, and we're going to be multiplying it by 1 second. So one of those second squares goes away, and we're left with an answer in simply meters per second. That's negative 9.81 meters per second. Final velocity 2. It's going to be the same thing, but the only thing that's going to change is our time. So it's going to be 0 plus negative 9.81 meters per second squared times 2 seconds. That gives us negative 19.6 meters per second after 2 seconds. And our velocity after 3 seconds is going to be 0 plus negative 9.81 meters per second squared times 3 seconds. And you can probably figure out what this will be as well. It's going to be negative 29.4 meters per second. So that's our time, or that's our velocity at time equals 1, velocity at time equals 2, and velocity at time equals 3. Now the question is, what's the ball's height after 1 second, 2 seconds, and 3 seconds? Again, let's write down our knowns. Our initial y position is 70 meters. Our initial velocity is 0 meters per second. Our acceleration, that's negative 9.81 meters per second squared. And we want to find the height, or that is the difference in the displacement. One way we can let's find an equation first. We want to find our YF at 1, 2, and 3 seconds. So we want to relate our yi, that is our initial y, and our final y, which means we need to find an equation that has delta y in it. Delta y, we're also going to be able to use initial velocity, because we have that, and we have our acceleration as well. And we also have time as well. We've got t equals 1, t equals 2, and t equals 3. So the question is, what is the what is the position at t equals 1 second, and 2 seconds, and 3 seconds? So we're actually told them as well. We need to calculate those three. The equation I'm thinking of that relates all these is our displacement, or the change in displacement, equals initial velocity times time plus 1/2 times acceleration times time squared. Now this first part we can break into two parts. That's going to be our YF minus YI equals all the rest of that. And if we want to solve simply for our final Y position for each of our three time frames, we're going to move our YI to the other side. So our YF is simply, and we're going to add YI to both sides, so YI plus initial velocity times time plus 1/2 times acceleration times time squared. Now again, since I wrote it like this, that acceleration is going to be negative 9.81 meters per second squared. So make sure, if you don't put the negative out front, you put the negative when you substitute in for the A. But now let's use this to plug in our values, and we can solve now for our final position after 1, 2, and 3 seconds. So YF1 equals, what's our initial Y? That's 70 meters plus, that's easy, plus 0 times time, our initial velocity rate here. That's going to be 0. Oh, I'm sorry. Get rid of that. Our initial velocity rate here is right there. That's going to be 0. So that whole middle part comes out, and I'll just get rid of that big ugly arrow again. But go away. There we go. So all this in the middle can go away because our initial velocity is nothing. It's 0. So simply we're going to have our initial position plus 1/2 AT squared. So plus, I'm going to put 0.5 instead of 1/2 because I like decimals better than fractions. Our acceleration is negative 9.81. And times t squared. Our time right here is 1 squared. Let's write all of our equations out, and then we'll just solve them all at once. So our YF2 equals 70 meters. Apparently I'm leaving the units out, which I shouldn't do, but I'll just keep the units out for now. 70 plus the middle part is 0, so that drops out. Plus 0.5 times negative 9.81. So that's 1/2 times our acceleration times our time, which now is 2 seconds. So that's going to be times 2 squared. And our YF3 is going to be 70 plus 1/2 times our acceleration, negative 9.81 times 3 squared. That should give us our three different positions after 1 second, 2 seconds, and 3 seconds. So what is that? We calculate each of these out. We're going to get 65.1 meters. And this is the actual position, not the difference below 70 meters. It's actually the position that they are height-wise as it drops down. After that, after 2 seconds, it's going to be 50.4 meters, the actual Y position. And after 3 seconds, it will drop yet further, and it will be all the way down to 25.9 meters. So we've got our YF1, YF2, and YF3. Our height, our 3 different heights after 1, 2, and 3 seconds of free fall. So there you have it. That is example 4 of the middle part of our notes on free fall.